We hear it all the time, right? Artificial intelligence is about to completely change medicine. It promises diagnoses that are faster, way more accurate, and available to more people than ever before. But what if this amazing tech has a huge, dangerous blind spot? What if the very code we're building to save lives is actually making our worst societal problems even worse? I mean, the potential here is enormous. We're talking about technology that could be like a superpowered second opinion for every doctor. Just imagine an AI that spots a tiny cancerous lesion on a scan that a human, no matter how skilled they are, might just miss. That's not just a quicker diagnosis. That's a life-saving head start. But here's the flip side. What if that exact same AI just doesn't work as well for you because of your race, your gender, or even the hospital you go to? Well, today we're going to dive deep into this really urgent issue of bias in medical AI. Okay, so here's our game plan. First, we're going to really understand what this problem looks like. Then, we'll play detective and trace the bias all the way back to its source. See how it gets baked right into the AI's code. We'll look at the very real human impact of these flaws and ask why we're so quick to trust these tools anyway. From there, we'll pivot to solutions, how we can build better, fairer AI. And we're going to end on a really interesting, kind of surprising question. Could bias, just maybe, be a force for good? So, let's talk about AI's blind spot in medicine. You know, when we hear the word bias, our minds usually jump to human prejudice. But in the world of AI, the issue is often something a little different. Something called statistical bias. This isn't about the machine having an opinion. Nope. It's about a fundamental flaw in its math. So, what is statistical bias? Well, to put it simply, it's not a random glitch. It's a built-in error in the system's logic that forces it to make the same kind of mistake over and over and over again. It's a flaw you can predict and reproduce every time. Okay, this dartboard analogy makes it all click. See, random error is like throwing darts all over the board. Your shots are scattered, they're imprecise, but systematic error, that's bias. That's totally different. It's like your aim is off. All your darts land in a nice, tight cluster, but they're in the wrong spot, completely missing the bullseye. The results are precise, but they are precisely wrong. And in medicine, being precisely wrong can have, well, devastating consequences. And here's a real-world consequence of that kind of error. Let's say you train a mammogram AI almost entirely on images from white patients. That AI might get incredibly good at reading those scans. But here's the problem. Black women have a higher incidence of dense breast tissue, which can look very different on a scan. So that same AI might consistently fail to spot tumors in their images. That's not a random mistake. That is a systematic failure coded right into the system, and it directly creates a life-threatening gap in healthcare. So you have to ask, where does this stuff actually come from? To figure that out, we need to follow the trail of breadcrumbs. We need to trace how bias creeps into an AI's development right from the very beginning. You know, pretty much every AI model goes through these 4 big stages. First, you handle the data, then you develop the model, then you evaluate how well it works, and finally, you deploy it out into the real world. The scary part? Bias can sneak in at every single step. It all kicks off with the data. The problem is often something called dirty data, and it's not just about the picture itself. Bias can hide absolutely anywhere. It could be in the metadata, like a wrong patient age. It could be a little physical marker on the scan that the AI accidentally learns is a sign of disease. It could even be a typo in the doctor's text report. It truly is a case of garbage in, garbage out. The AI can only ever be as good as the data we feed it. And there are just so many other traps. You've got class imbalance, which is when you have way too many normal examples and not nearly enough examples of the rare disease you're actually hunting for. There's sampling bias, which happens if all your data comes from just one hospital and doesn't represent everyone. And you even have annotator bias. That's when the human experts who are labeling the data accidentally bake their own assumptions into the process. All right, moving on to the development stage, we run into this really sneaky issue called data leakage. This is basically when the AI cheats on its test. It gets a little peek at information it's not supposed to see during its training. And the result? It looks like a total genius in the lab, scoring off the charts on accuracy. But then, the moment it sees brand new, real-world data, it just completely falls apart. And that brings us to the final step, deployment in the real world. This graph here shows a huge problem called data distribution shift. The AI was trained on one kind of data, the blackouts, and it learned that pattern perfectly. But then, you release it, and it suddenly encounters a totally different reality, the purple diamonds. Now, this can happen for all sorts of reasons. Maybe a hospital gets a new X-ray machine, or the patient population in that area changes. The outcome is always the same. The model, which was trained on the old reality, is now totally unreliable and potentially really dangerous. Okay, so we've looked at all the technical flaws, but these aren't just abstract computer science problems, right? Let's talk about how this flawed code turns into flawed medical care and what the real human cost actually is. This flowchart right here is so important. It shows this dangerous feedback loop, a vicious cycle. You start with bias model development. That leads to a biased tool being used by doctors, which then influences biased clinical decisions. And guess what? Those decisions create more biased data, which then gets fed back into the system to train the next generation of AI tools. It's a cycle that, if we don't stop it, can just keep making health disparities worse and worse over time. And if you're thinking, well, can't we just remove the sensitive data, like race? Think again. In a discovery that is honestly startling, researchers found that some AI models can predict a patient's self-identified race just by looking at their chest X-ray, with startling accuracy. And here's the kicker. We don't even know how they're doing it. It just goes to show you that societal biases are embedded so deep in our data that an AI can find them and learn them even when we try our best to hide them. So the problem isn't just with the AI itself. Part of it is actually with us. See, we have this natural tendency to trust computers, and that can turn a flawed tool into a really dangerous one. This phenomenon has a name. It's called automation bias. Automation bias is basically our reflex to just go along with what the machine says, even when our own gut feeling might be screaming that something's off. Picture a really busy doctor. They're under a ton of pressure. It can be so tempting to just accept the AI's answer without giving it a second thought. And in that moment, we've basically handed over our critical thinking to an algorithm. Now, this bias can lead to two very dangerous types of mistakes. On one hand, you have omission errors. That's when we fail to catch something the AI got wrong, like if the AI misses a tumor and the doctor, trusting the machine, misses it too. But commission errors are maybe even scarier. That's when a doctor actively follows an incorrect suggestion from the AI, literally overriding their own better judgment to do what the machine says. Okay, so that's the problem, and yeah, it is complex. It's deep-rooted. But the good news is that experts are already on it. They're developing a blueprint for how to fix this and how to build fairer, smarter AI for everyone. Hey, remember that vicious cycle of bias we just talked about? Well, this is the virtuous cycle that can replace it. This framework shows that we can, and we absolutely must, step in every single stage. It starts with carefully defining the medical problem and checking it for historical inequities. It means building diverse data sets, standardizing how we label them. And then, this is key, continuously monitoring the AI's performance long after it's been deployed. And that brings us to our last section. And honestly, it might be the most thought-provoking one. We've spent all this time talking about bias as this terrible thing we have to get rid of. But what if, in certain cases, bias could actually be part of the solution? Just look at this comparison. On the left, you have inequitable bias. That's the harmful kind we've been talking about. It's what happens when you train a model on a majority group and then apply it to a minority group, which can cause real harm. But on the right, you have something called equitable bias. This is completely different. This is when we mindfully and deliberately create a biased data set, say by oversampling images from an underrepresented group, so we can build a specialized model that is fine-tuned to serve that specific group's needs. It's a way of using bias to actively correct for the imbalances of the past. And so, this is the challenge we're left with. AI has this almost unbelievable power to heal. But to actually unlock that promise for everyone, we have to be vigilant, we have to be transparent, and we have to be intentional about every single step of the process. It forces us to move beyond just building code that works, and to start building code that works for everyone. This challenge isn't just technical, it's deeply, deeply human. And our health and our lives really do hang in the balance.